In this video, we're going to talk about section 9.3, and we're going to continue finding area, but we're going to find area of what we call composite figures. This just means it's a figure that's composed of more than one shape that we know. So like this picture, also it says shaded. This is the part that's supposed to be shaded, you guys. So if you want to shade that in. Okay, so this shape is composite because it's kind of comprised of a rectangle with two semicircles taken out. Okay, so if I want to find the area of the shaded, and I kind of like to use this like subscript and make myself a game plan. So if I do the area of the rectangle and then subtract off the two semicircles, that's going to give me the area that I want. Now, two semicircles added together is just one circle. So I'm going to do the area of the rectangle minus area of the circle. Okay, so I need to find these two areas. So we know the area of the rectangle is base times height, right? So my base is this distance across here, which is 23, and my height is 16. So we're going to do 16 times 23. Sorry, I'm going to switch the order just so I'm matching up with my variables. So 23 times 16. So the area of the rectangle, pull my calculator here. Okay, so we are going to do, put it where you guys can see it too. So we're going to do 23 times 16. And we get 368, and this is in feet, so it's going to be square feet. Okay, so now the area of the circle is pi r squared. So we need to figure out what is the radius of the circle. So if we go back here, 16 is this distance all the way across. So all the way across here is 16. That is the diameter of the circle. So remember, radius is the distance from the center to the outside. So the radius then has to be equal to 8, half of 16. So we're going to plug in 8 for r. So we're going to do 8 squared times pi. In the circle video, we left this as 64 pi. Because I have to combine it with something that doesn't involve pi, we're going to go ahead and turn that to a decimal. So I'm going to do 8 squared and then times pi. Okay, your calculators do have a pi button. Mine is above the caret symbol here. Okay, so 201.06. I'm going to round two places. So we have 201.06 square feet. Okay, so now I'm going to subtract those two. Okay, and then that is my area of the shaded region. So I'm going to come up here and grab 368 minus, I'm going to use the answer I got, so second, and then the negative sign will do that. So we get 166.94 if I round to the hundreds place. So the area of shaded equals 166.94. Square feet. Okay, this says find the probability of a point chosen at random is inside the rectangle but not in the area above. Okay, so probability, I'm just going to define right here. Probability is what you want. I'm going to put desired outcome over the possible outcomes. Okay, so the desired outcome is I want it inside the rectangle but not in the shaded region. So that would actually be within the circles. So my desired outcome is the area of the circles. So what I want is area, I'm just going to do this below, is the area of the circle. That's my desired outcome. I want it to be not in the shaded region, but inside the overall rectangle. Now the possible outcome is the whole rectangle. It could land anywhere in the rectangle. So the area of the rectangle is my all the possible outcomes. So we actually just found these from up above. So area of the circle is this guy. So we've got 201.06 divided by 368. Okay, so if we do that, we have 201.06 divided by 368.55. So that's approximately 0.55. Probability you can present as a fraction, as a decimal, or as a percent. If you want to change it to a percent, you just move the decimal 2 places to the right. So we could say there is a 55% chance that if I randomly pick any point in the rectangle, it's going to land not in the shaded region, okay? So either of these is fine, 0.55 or 55%. Okay, another composite figure we're asked to find the area for. So you can kind of see this, that I have like a rectangle here, and then I have a triangle, and it's actually a right triangle if I drop that straight down, right? Because this rectangle has to also have a right angle. So the rectangle plus the triangle is going to be the total area. So I'm going to say area total is area of the triangle. I'm just going to use some symbols here. Plus area of the rectangle. Okay, so let's start with area of the rectangle. So we know area of the rectangle is base times height. So the base here is 37.5 and the height is 22.5. So that area, when I multiply those two numbers here, again, kind of put that where you guys can see it. There we go. All right, so we have 37.5 times 2.5, 843.75. All right, so that is the area of the rectangle. This one's in meters, so square meters. Okay, now area of the triangle. So area of the triangle is equal to base times height divided by 2. Okay, so we need a couple things. We need to know this base right here, right? And I need to know this height. Well, we can figure out the base, so I'm just going to call this B for now. So this base, the whole thing is 75, so if we subtract off 37.5, okay, so I'm going to do that. 75 minus 37.5 is 37.5. So that means this piece right here is 37.5. Okay, so we have the base. So again, back to my area of the triangle, we have 37.5 as the base. Now we need the height, okay? And then divided by 2. All right, so the height. Well, I know 2 of the sides. I know the hypotenuse and one of the legs, and we're trying to find this other leg. So I'm going to use Pythagorean theorem since it's a right triangle. So I'm just going to call this side, we'll go ahead and call it H since we're finding the height. Okay, so I'm just going to redraw so you guys can see that. So we've got 37.5, 62.5, or maybe I'm just going to call it X since we're using H a couple places. Okay, so we have A squared plus B squared equals C squared. 62.5 must be our C because it's the hypotenuse, so I'm going to square both of those. Okay, so 37.5 squared is 1406.25. Now we're going to do 62.5 squared is 3,906.25. Okay, so now I want to get x squared by itself, so I'm going to subtract the 1406. Okay, and let's see, what are we left there? 2,500. So then lastly, we're going to take the square root of that. So square root of 2,500. And we get 50. So x is equal to 50. So x for us was the height of this triangle. So now I'm going to take 50 and plug it in here. Okay, So we have 37.5 times 50 divided by 2. So 37.5 times 50, and then divide by 2. So 937.5. So area of the triangle, 937.5 square meters. Okay, so total, now we're going to add those together. So we've got, I'm just going to write total here. So I'm going to do 843.75 plus 937.5, so plus 843.75, making sure I'm putting the right numbers in there. Okay, so there is our total area, 1781.25, again, square meters. So what we did is we added those two together to get this number. Okay, guys, that is all for this video. Thanks for watching.